Okay, thank you very much. As you can possibly read on the slides, you've got the link to download the slides if you want to have them on your laptop while we are presenting. Actually, it's the version just slightly before this one because I modified the slides like 30 minutes ago. So we organized the CTF that was in late November this year, and it was a CTF dedicated to smart devices. So this is how we will organize the talk a little bit. At the beginning, I'll talk to you about like how we built the infrastructure, some generic stuff, and then we will get into some of the most interesting challenges and not explaining you how to solve them because that you can see it already on the GitHub on the write-ups, but how we created them, right? So who are we? Well, I am Axelle. I am an antivirus researcher for Fortinet, and I am working specifically on mobile malware for smart things, where smart things range from smartphones to smart toothbrushes to plenty of stuff.
Hello, I'm Phil. I'm always doing hardware ranking since a long time now. And I belong to the former team of GROAC conference and CTF. And since 1 year, I'm involved in the Ph0wn CTF organization.
So this is like all the devices we kind of used for the CTF. So you see, well, there's a drone, a weather station, we'll discuss that one quite later, a Bluetooth device. So I don't know if you attended like 2 talks before this one. There was a talk on BLE on the other track, I think. Well, this one was pretty lots of similarities. We had also here, you have smart glasses. Here we have a simulator of washing machine, so you could wash your laundry actually during the CTF. This one, perhaps some of you will recognize it. It's the Black Alps badge, but it had been customized with a challenge for Ph0wn. We have, of course, a toothbrush. It's important, a smart toothbrush, right? With challenges on that one. We had also an Android application controlling a home safety alarm. Several retro games hacked. You've got one edition there on the booth outside. Of course, a camera. You've got to have a camera, right, for IoT, so we had a camera. And then we had people also working on hardware challenges. They had like badges, specific badges that had intentionally been broken, and so they had to solder it back to recover the flag. And we had a little bit of Arduino. Ph0wn. Well, the name actually dates back to 2013. Right, so it was really a long time ago. At that time, I was thinking about doing a conference on IoT, and, well, it evolved gradually to, well, a CTF. And so the CTF was born. We started up with a core team, like, well, that was 1 year ago, March. And the CTF itself was end of November. So that was like all the time frame where we had to get all the work done. One of the major milestones there is that we had end of June an internal CTF at Fortinet. So that was quite easy just to test our infrastructure and make sure that things would be working correctly, right? And then, well, meanwhile, that time, well, we had to create the challenges, test them, and ensure that we had enough stuff for everybody to have fun on the day. Stats. So, how long does it take to create a challenge? Well, that's the question we have most of the time. And it's a difficult question because most of the time I'm unable to answer it because it begins with lots of research, right? So we reuse some prior research for some things that we did and turn it into a challenge. So should we take into account the time, like the months or the years of research for the challenge or not? I don't know exactly the answer to that one. The other issue, of course, is like certainly all of you. We seldom have like a full week to dedicate to the CTF. We rather have like 2 hours in a row, then we get interrupted, and then we have a little bit more of time on the next day and things like that. So it's like scattered during months, but rarely like 1 month entirely dedicated to a given challenge, right? At some point, I think one of us got so much annoyed of being interrupted all the time that he named one of his challenges Interrupted Secrets. So, how long? I'll try a little bit to answer the question. So these are days, right? And basically you've got blue lines. Blue lines is how long it took us to really design the challenge. It's basically time that we had expected to spend on the challenge to create it. And the red line is the bad line, kind of. It's how long it took us to deploy it, because it's different to have a challenge or something which is working for one person and to have it working for a CTF, so for many participants. And of course, as you can see, we have some bad surprises from time to time where some challenges didn't work at all the way we expected they would. And we spent lots of times trying to deploy sometimes kind of easy challenges because it wasn't working the way we wanted it. Oops, this one is a little bit fast. We also had, fortunately, a few good surprises at the end. So like those 2 challenges, one on a drone and the other one, the rework, this is the hardware challenge. Well, we didn't spend lots of time creating it, and they work straight away. That's like, we'd love to have more of these, right? The audience, well, we had like 55 players. Sorry, so if we are a marketing team, we'd say we had 200, but really only 55. And we had 16 teams. 11 managed to score at least once and stay really long during the night. So we'd say that 11 teams really had fun. What we had intended is also that we wanted to have some simple challenges so that everybody would have the chance to score at least once. That was good because we had really several challenges, 50-point challenges, and many teams managed to score those. What we hadn't anticipated was that we had quite a few 500 points challenges, I don't know, 3 or 4, and we had expected at least one of those to be solved during the CTF, but that didn't happen. Nobody solved them. So either they were too difficult, either they didn't have enough time. I don't know. Well, it's difficult to know. As for the audience, if you want to know, well, it was roughly half students and the other half scattered between like many different groups, engineers, researchers, business people, very various people there. We also asked them roughly their level. So a little bit more than a half told us that they were really newbies to CTF, while the others were experienced in playing to CTFs. Just beware though that newbie there, they were newbie to CTFs, but not newbie, of course, to their topics. They were experienced on their own topics there. The organization. So the core team of Ph0wn is consists in 8 people, I think. And we decided that we would share information among us without any restriction. So we wouldn't have like one person dedicated to a given challenge and secretly keeping it. No, everybody could have access to whatever they wanted. And we shared everything just very simply on GitLab. On our point of view, it worked fine, right? The other thing is also that we decided that, well, everybody agreed that it was good to test challenges. On that point, everybody was okay with that. The problem is that when we really had to test them, well, at night at home testing it, it's a little bit difficult. You're alone and you don't always all the time feel like testing stuff like that. So it didn't really work out that well. So we thought that it would be working better, at least in small groups. That was one solution there. And the other thing is that we were having like regular meetings, at least for the organization part of Ph0wn. And our our meetings, if it was just like to say, okay, we need 50 bottles of water, or if we need to have this and that ads there or things like that, they were kind of boring, right? So we thought, okay, the only solution to do it is to put the test sessions in our meetings. So we had one 1 hour meeting for all the organization stuff, and then 2 hours testing the various challenges that were ready at that time. That worked. We found lots. It's really important to test the challenges. I'm sure that people for the CTF here, when they organize it, they test it. We found loads of bugs in the formats of flags, and it's sometimes difficult for smart devices to follow a strict format. We found errors in the descriptions. We even found actually vulnerabilities on also the smart devices, right? The equipment. So what's your preferred equipment? I'm sure you'll agree that this bottle was very useful. But we also had like loads of equipment there. So here it was, well, we were being sponsored by Fortinet, so it was very easy. I'm working at Fortinet. It was easy for me to say, oh, okay, we need this or that switch there. And that was the cool part of it. So we could just say, we need this or that and just borrow them. And we took all equipment in spare because, you know, never know. Well, our equipment is very robust, but never know. We took it twice. Whatever happens, if ever something happens, well, we can switch to another one. But well, we hadn't anticipated moving that load of stuff, but it ended up like 2 cars full of materials. That's the network infrastructure. So it's pretty simple, but different to the CTF here in Insomnihack, where you are wired connection. Here it was Wi-Fi, so we had access points distributing the phone's CTF Wi-Fi for the participants. They were getting connected here to this server, which is running CTFD. CTFD is a framework for CTFs, which is open source, and we reuse that that way. And then we had some challenges which were like offloaded to another challenge server, where we had like loads of Docker containers there to have the various challenges be kind of contained with each others. We had also equipment like cameras there on there, specific Wi-Fi for our drone. That's about it. On the console of the CTFD, you have logs, and we had a look at those, and that's one of my personal surprises, is that both in the internal CTF at Fortinet and at Ph0wn, people seem like to brute force flags. I mean, honestly, if you are CTF players, don't do that. That's totally stupid. I mean, there's no way this is gonna work. The only thing that might happen is that you just might get yourselves banned by the CTF team. But well, okay. Slightly more disciplined approach. So this was for the challenge on the Black Alps badge. Well, there was a binary there, and some teams were apparently trying all the strings that they found in the binary as flags, right? So that's a little bit more clever, but of course it didn't work, but it was funny, so I thought I would put it on the slides. Another funny one, I'm not sure it's totally readable, but we have some teams try, I don't know if it was intended as an SQL injection attempt, but that's their team name. And they did play the CTF, so it probably wasn't fully just an attack. So that's another funny name there. So, lessons learned. Well, we had 25 challenges for 8 hours, but 25 challenges, all with various equipments. And some of them, like seven were never solved at all, and some of the 7 were hardly even looked at. So that obviously means that we had too many challenges, given the amount of time to get into each of the challenge, of course. As for the equipment, well, we bought one of the challenges there, but otherwise we had like an enormous table where we would lend equipment for everybody. We didn't have 55 equipments for each of the challenge. So the teams had to come and write their name down on a sheet of paper, and they would borrow the equipment for 10 minutes. We quickly noticed that this was really far too short for them to test it. So we extended it to 20 minutes. Otherwise, they hardly had the time just to borrow the equipment, look at it a little bit, and do anything with it. We also had some teams, who were actually borrowing the equipment, but, they didn't know it, but they weren't borrowing at the right time, so they weren't in the stage where they could really do something with it. So that's kind of a little bit more difficult, but they didn't really use their time when they really had the equipment. So that's a little bit more difficult to solve. The other thing is that we had also specifically intended some of the challenges not to need any equipment at all, so that while a team didn't have any equipment, they could still do something. And we didn't highlight those challenges enough, so they could have used their time probably a little bit better on that part. As for the network, we were hosted by the local university. I don't know how it runs here or in other CTFs, but one thing is for sure is that no venue likes to host a CTF network where you have uncontrolled and unknown stuff which is going to happen. So we had to take on ourselves responsibility for that and say, okay, we are, as the foreign organizers, responsible for what will happen. And very fortunately, all participants were very clean on that, and there was no problem at all. But, it's something that you need to be aware of. A big issue, of course, we didn't have enough drinks.
And even no beer.
We had planned, but that was very dumb of us. We had planned like water for just a meal. Right. But people were staying like 8 hours, so they needed to drink after the meal, obviously, right? So we ended up going to the supermarket and buy some more bottles of water. And then when the supermarkets were closed, we had to refill the bottles. So that's really a great task for organizers, refilling bottles of water. And finally, of course, as it was the first edition, that's obvious. It's very difficult the first time to spread the word to people and let them know there is a cool CTF around, do come, and everything, right? So now the making of, and that's your turn.
It's my turn. So about the weather station, here it's a focus from an idea to a fully functional object. So how I build it. First, all the challenges must be accessible to newcomer and should interest skilled people. And another important thing to me was this object must look like stuff you find in real life. This means that the design of the firmware must contain most common flows you can find on other IoTs or embedded objects. So if you're a newcomer to pen test those kind of device, you will have some clues of what to search and what you expect to find on other hardware. And so I decided to build simply a weather station. Those weather stations you can find for cheap on the Chinese markets. About specification, the hardware spec. My first idea was to take an Arduino board. Arduino have shields. Shields are easy to build. And so I end up with a problem that if you want to give the control to your device to people, because of the Harvard architectures, you need to build option to find gadget, etc. And that's not so easy for newcomer and in a CTF context for a first time. So I give up with the Arduino boards. But as shields are easy to build and are really cool to use on those boards, I select another board, the Nucleus 64 boards from ST. This board has the big advantage to have STM32 CPUs. This means ARM targets, and as ARM targets are more common and more easy to exploit, you have a lot of resources on the internet, and so you can give a try even if you don't know it at all. And last thing about all the sensors I've used on the weather station. A common mistake is to choose sensors with different buses or even custom buses. It's a waste of time and resources on the CPU. So I choose only a sensor. We use an I2C, a simple I2C buses, and hook them together. It was more easy to develop. And when you prototype something like that, don't forget the Chinese market. On the $1 basis, you can find a lot of modules. All are really wired on a PCB, and so you can really prototype fast. The OLED display was a little bit pricey. It's something like $4. So here is the first prototype, and the only one I've used during all the development phases. Only a simple breadboard with all the sensor plugs in it. It was quite stable. But on the right of the screen, you can remark there is a logical analyzer. If you start a job like that, it's really easy to use even the simplest version of a logical analyzer, a first price. It really helps you to go faster, to stabilize everything on your buses and all hardware glitches. And so, just 1 month before the CTF, the first version of the ready-made weather station was ready to be shipped to other friends of the organization staff to doing a challenge review and evaluation. And if you wonder it for the next edition, maybe I learn on my to-do list, I add to my to-do list, sorry, to learn KiCad and maybe send my files to dirtypcbs.com. I promise it. About the development tools. When I start the development, I've done what I usually do. I take VI, create a makefile, do an hello world and GCC it, and everything was okay. But this time, I look further and I've looked what ST offers as free tools. They said, we have for free some professional tools. So I've tried them, and I must say that I were very surprised. I used CubeMX to generate the skeleton of the project and then import it in System Workbench, a sort of Eclipse dedicated to STM32 boards. And it was quite a good surprise because I had the benefits of a nice graphic user interface and a real-time debugger. It was really more easy to stabilize everything during the development phases. And another benefits of those kind of high-level development tools are the hardware abstraction layer. They give lots of libraries, and you can import them in your projects, and they are ready-made and really useful. And I must say that I learned a lot of things using those tools. About the challenges. The first challenges was to get the competitor to bring them they must connect their computer to the weather station. And my first idea was to let some free pins on the board and to give wires and the serial modules to competitors, and they need to wire it on the board. That was not a really good idea for the safety of the weather station because of shortcuts, etc. So I changed my mind and I directly solder the USB to serial module conversion to the shield and only give USB cable to the competitor. Even with that, I had several issues to solve with them, with a driver not running correctly, but it was a FTDI simple drivers. And even I need to help some team with the baud rate guessing over the serial lines. But it was a 50-point challenge. For the level 2, the reverse start here. Something common and a common mistake you can find in firmwares is the use of static password included in the firmwares. And so I've built such things, and I've used my own hashing algorithm. It was an easy one with only XORs and adds, but it was easy to reverse. And I give it a try with Radar 2, it was okay. And then I check with IDA Pro and the magical F5 key with the X-ray decompiler. The problem with the X-ray, that it really kills the game because it recovers my source code, my original source code. So the competitor doesn't have anything to do if they have IDA Pro. So I changed my mind, and I look about the code generation, and I've moved from the default 0 to the 03. So you can see that the algorithm is not anymore recovered by IDA Pro, but the side effect is that it was not easy to read it with Radar 2, for example. All the strings were removed from the data zones, so you can't do X reference, you can't see anymore the strings. So it was too much complex for a newcomer. So I've tried several optimization flags, and the best average between IDA doesn't produce exactly my algorithm and something easy readable by humans are the flag OG. That was the solution to break the IDA decompilation stage. About the level 3, the serious thing starts here because it was an exploitation. As we are in south of France, the challenge asks you what happened when winter is coming. That's no way that we get temperature cold and under 0 degrees. So you need to discover what the weather station will display when the temperature gets below to 0. So it was a buffer overflow. You need to find it in the firmwares. Then you need to find the correct part of the code to call. About this one, it was quite obvious to spot the buffer overflow because there is only 2 places in the firmware where you can enter a string. And it asks you, please do not enter more than HR. So it was given to the competitors, but I had an issue with this one. As you are completely blind when you're connected to the weather station, you don't have any debugger, you don't have any stack on your arrays, you just do things blind. So when the function asks you to enter serial chars, when you go very far away in the stack, you cross the red box, which is the return address to smash, and you don't have any feedback. So you can really go further what it's needed. And competitor doesn't have a feedback that his overflow was efficient. So I changed my simple code would do pulling data from the serial line and store them to the buffer in the stack. I've moved this code to and fully interrupted code will handle the serial byte with interrupt and DMA, and then doing this completely change the stack layout. So the blue box you see on screen are the place where the interrupt used some really mandatory bytes to not smash when you enter a char over the serial lines. So when people cross the blue box, the weather station crash at the second. So they have a feedback and they know that they have a boundary to not go further. And it's for sure the return address is before this boundary. And here is what you see on the serial line when you crash the weather station. So on the terminal, the competitor have a feedback now in real time. But with a nice OLED display, I've done a little things better. I've popped a debugger and I trap everything weird on the ARM when they crash the stack and when the overflow gets wrong. And so there is 2 bombs. Bruno guessed it. Those 2 bombs came from Atari. When an Atari crash, it gives you this screen. For example, when you have an illegal instruction, you have 4 bombs. That was the only debugger an Atari popped you. Nowadays, the computers are more friendly with developers. About these little debuggers, I had to figure out how to write a sort of catch-all. On the ARM CPUs, when at the beginning of the flash, you have a bunch of vectors. The first vector are for the stack and the reset handler, but just after, you have a lot of handlers who can catch all the events who happen, and even when something gets wrong, like non-maskable interruption, bus error, etc., you can tweak some code. By default, the compiler sets them to a simple return statement, so you have to change, to override those values and to point to your code. So you can pop a debugger when any weird things can happen, and you can inform the player that something gets wrong and he needs to change his offset and so. So for the buffer overflow, it's okay. Now they need to spot in the firmware where is the code who handle the winter parts. Here it was quite obvious because in the data zone you have a string with called winter is coming. You just need to dereference the pointer and to spot, and it was easy to spot the function. We use this string. And last thing you need to do is to write a Python script who send everything at the right moment over the serial line, and then you got the exploit running. So let's go for a demo. We have the weather station here with the camera.
So, yeah, that should be pretty okay. I'm gonna even, well, you're not blind, but I am, so let's make it big. And hopefully that is okay. Okay, so that's the normal weather station there. So it's like 25 degrees. Pretty hot under the camera, right? We've got to reboot it. So the camera, the weather station is rebooting. Do you want to? And the script is running, waits for the camera to reboot. We get into there. That's where it asks for the password. So we have our script send the password. And then we are going to send the right buffer overflow. And yeah, you get winter is coming, the pop-up with the flag.
Okay, so the flag was here. Okay, this one was a backup flag, backup slide because of Murphy's law, you never know. And you have the payload under it. You need to send, instead of the name of the weather station, you should enter. And last thing about the display of this flag. In real life, it will not happen as is because the weather station the display of the weather station was working fully interrupted. This means that you have 3 displays per second, and when you jump to the code where the flag was displayed, you would just see in for a few milliseconds, and then it would be refreshed by the normal interrupt. So I was kind with competitors, and I stopped all the interruption just before displaying the flag and enter to a dead loop. So if it's happened to you in real life, the things you need to do is not a simple overflow, but a piece of code will stop interrupt and clear the watchdog timer to, after that, display everything you want on the screen of the device you are just about to hack. But as it was a simple buffer overflow, I've simplified it like that. Another cool thing about STM32 is that each CPUs, even the $3 ones, the cheapest, have a unique serial number inside. This serial number is derived from the batch number, the silicon slice, etc. It's not intended to do cryptography with that. There is not too much entropy, but you can track all the STM32 you are on the network, in fact. So the goal of this last challenge was to recover this serial number from the CPU. On this one, there was two paths, in fact, to achieve this. You can have some help with hardware, and you can find the solution with only software. The common task for the two paths was to recover to reverse what happened during the boot process of the weather station. The weather station is just wait for an imaginary probes and do a sort of challenge response. And if you send the good values at the good moments, you will get the serial number and the flag with it. So the challenge response was quite simple. The question was, what is the 2 byte at address dead? If it's BIF, I will output the serial number and the flag. With the hardware, it was quite, the hardware solution, the hardware way, it was quite simple to connect over the I2C buses a logical analyzer and to see the first byte was, in this case, DE. So this means that's the first byte of the address. So you can know that you can be quite confident about the reverse you've just done. And then to finish, you need Rabus, for example, or bus pirate or a device like that to hook to the I2C buses, and you need to finish to implement the challenge response, and then you got the flags on your I2C bus. The software way. The software way was a little more complicated than a simple buffer overflow, because you need to take the value from the RAM and output them from the serial lines. So you need to write a dump code, a sort of ARM shell codes who do the job for you. The first things to find is where to store the dump codes in the weather station. The most hard way was to use the stack, because you don't have a fixed point in memory. With the stack, you never know where the stack is. You can brute force it, but that's not so easy. The easy way was to come back to level 2. It was a static password with a fixed line, and the size of the buffer used to compute the hash of the password was 666 bytes. That was not a coincidence, and you can pad every data you need just after the 8 byte of the password. So you have the right and all the room you need to put your shell codes here. About the dump codes. The dump codes was in fact simple. You just need to spot in the firmware where is the serial number computes and the flag is decodes. And then you just need to call this function. That's the first branch. And then the second branch is simply the printf function to print the buffer over the serial lines. And then you end in a dead loop, so you don't have timing issue. You have plenty of time to read what happened on the serial links. And when everything was well done, you have the serial number of the STM32. It's a real one, and then you have the flag just after. Only one team were in the way to find it, but they find where the dump code, the serial number was computed, but they didn't find a way to store their dump code over the RAM or the stack, so they left off. And it was the last challenge for the weather station.
So some other challenges. So I told you we also had a home alarm, right? And so this one started off like in 2015. Out of some research, I found some vulnerabilities in the mobile application for this home safety alarm. And then thinking like years later after on the phone, I thought, well, it would maybe be a good idea to write a mobile application for the phone, for the home safety alarm, but something that would be a little bit more secure, right? So I started writing the application to fixing kind of some bugs. And then, well, that's when I actually bumped into something interesting to actually hide part of the flag. So this is Dalvik bytecode, right? And this is a packed switch. You don't need to understand all the internals there, but basically you've got a switch and you've got different cases. And it happens that quite surprisingly, if you put something in the middle of cases, so you've got case A, case B, case C, for instance, and you put something in between case A and case B, well, no decompiler, no disassembler sees that code. So that was really very interesting. I tested then that over plenty of different tools on Android. So you've got Jeb, you've got DAD, you've got AndroGuard, you've got Code Inspect, Dex2Jar. Nobody was seeing correctly that code there. So I thought, oh, that's great. I'm going to hide the flag partly there. I didn't exactly hide the flag there because I wanted it to be a little bit more difficult. So I hid an entire XOR function with a key, and you just had to kind of XOR that key. You would find a password, and that would be the password actually to enter to secure your home safety alarm. And then when you would enter that password on the Android application, well, you would get all the settings for your home safety alarm. And in those settings, you would see the flag in there. So that was what was perhaps cool is that this challenge did not need any equipment because I was just giving away an APK, so a file. But people were actually, I'm not sure that all participants were aware of that, but they were really working on a real home safety alarm or mobile application for a home safety alarm. Other challenge. So this one is a very interesting challenge on Bluetooth Low Energy. It's really interesting, honestly. Well, I'm biased. I wrote it, of course, but well. As you perhaps remember from a previous talk, so what you have when you create a Bluetooth Low Energy device, you have services and characteristics, right? Characteristics are like the features that you want to export, and services tend to group those characteristics inside those. And I had one characteristic with an encrypted message, right? So of course, the goal of the challenge was to decrypt that message there. And here, the key thing for participants were to notice that the UUID, which is the type of those characteristics and services, well, they looked like this one, for instance. And if you have a close look at that, this is only ASCII characters. And if you print that, well, it tells you Kylo Ren is bad Jedi. That's my opinion, right? Okay. So that's the first part. So you got one text, actually a key, and then in the other one for the service UUID, this time it told you that you had an AES message to decrypt, that this encrypted message was encrypted using AES. Quickly, not very, don't need really to be very smart there. While you use Kylo Ren is a bad Jedi as a key to decrypt the message, and then it gives you the plain text, and you send that back to the device, the Bluetooth device, and the Bluetooth device sends you back the flag to send to the CTF server. Worked very fine. So then I thought, okay, now I need something portable, so I'm going to Dockerize it. So I Dockerized it, and I was very proud of myself because it was working really great, right? It worked absolutely great when I was alone. Then what happens when you're two? Well, well, our previous speaker noticed that there is an issue there because actually BLE only handles one person at a time. Once you are connected, all the others, well, just wait, right? So that was an issue I had to handle, of course. The other thing, of course, is that I don't want one team to solve the challenge and then the other team just to connect and get the flag right. That wouldn't be fair, right? So that was another thing to solve. So that's how I solved it. I thought, okay, well, I can't have two people connect at the same time, but what I can at least do is I will disconnect every participant after 90 seconds, right? So you've got 90 seconds to take a screenshot of the plain text, work on it, and then you connect again and decrypt it and something like that. Seemed like kind of reasonable. And of course, so that one team would not recover the flag of another team, well, when they disconnected, I would reset the status of the device, right? So looks like reasonable there. 10 persons, well, no, didn't work at all. I mean, when you have 10 persons trying to connect on a BLE device, everybody kind of competing and trying to connect to it, it was awful. Nobody managed like to connect, or we had one person connecting, but only for a very short time. So we thought, okay, what can we do? We're gonna put a second device, like just a copycat of the first one. But this one, we will book it. We will ask teams to come and book it and have it like for other equipments reserved for like a 20-minute time slot. And it will be like reserved to their MAC address, and only them will be able to connect to it. But they will have it for the time that they need. Theoretically, this should have worked also pretty well, except that, well, it's BLE and you always have bad surprises with that. And just the mere fact that teams were trying to connect, even if they were exactly disconnected straight after because they didn't have the right MAC address, was enough to disrupt a little bit the service. So I know that many teams, unfortunately, while we were running the CTF, had the unsatisfaction of having difficulties to connect. So like, I don't know, 1 hour before the end of the CTF, when I saw that teams were really having issues to connect, I came over and showed them like the screenshot they should have taken like 1 hour ago so that they could go on and do the rest of the challenge. So that was like a poor experience, although honestly, the challenge was fun. The web camera. So this one was intended to be a very easy challenge, right? We wanted a 50-point challenge, so nothing too difficult to be done there. We had one of our cameras there, and the idea is that I had shot a movie of myself in our labs with posted there with a flag, right? Okay, so I'm not writing any flag or any password on my stickers except for CTFs. Well, so what people had to do is they had to log in on the camera and search a little bit on the web interface, notice this movie, and get the flag there. Not too difficult. The problem is that once they log on the camera, they are admin on the camera. And I'm sure you would have had plenty of nasty ideas like, can I reboot the camera? Can I change the credentials? Can I remove the movie? Yeah, things like that. And obviously, I had to do something about that and make sure that they wouldn't be able to do it. So we basically had to secure the camera with putting in front of it a FortiGate and filtering out all the URLs that we didn't want participants to be able to reach. So you see, for instance, here we were ruling out hard factory reset, and all those stuff so that participants couldn't do it. It worked pretty well because actually the web interface was JavaScript, so they were under the impression that what they were doing was working, while actually it was being blocked behind it. So, well, how did it work? In the end, it worked pretty well. So for us, it was great because we had 2 cameras to spy on participants. So you can see that was fun. We could watch them soldering and things like that. That was the cool part. We were surprised because those live streams were actually open during the CTF, and we thought that some teams would connect to those and have fun as well, but no, didn't seem so. A little bit surprising as well, the movie was, of course, on the SD card, which was inserted on the webcam, and no team thought about grabbing the SD card and dumping it. Well, you know, you never think about everything, but it would have been an easy solution, of course. And then the final message for that one is that we didn't give at any time the credentials to log in on the camera. The competitors had to find those. And we had just set the default password there. And nobody came ever to ask us for the credentials. So this is a clear message. If you are a system administrator or a vendor, you've got to change the default passwords, because any CTF participants just find it in less than 5 minutes, right? Another challenge. Well, this one was cool as well. We had a drone, right? And of course, the challenge was, well, you had to have the drone take off. But you didn't know anything about that drone except that it was a Ph0wn drone, but that was about it, right? And all the tools which existed, well, were using the fact that the drone was connected on a default IP address. And of course, for a challenge, we didn't want like a standard tool to be working. So we hacked the drone and we added support to WPA2 to be able to connect it to our Wi-Fi and change the IP address of the drone. So what the participants had to do is first find the IP address of the drone on the Wi-Fi. That's not too difficult, to be honest. But then after that, they had to write their own tools or hack existing tools to get the drone to take off. One of the teams managed to find a project on GitHub which was doing it pretty well, and they did it. I saw their code. It was like 5 lines of code, and they managed to get it fly. That was really cool. Another team did it a kind of funny way, an original way. They brute forced the GPIOs of each of the motors of the drone to have it turn, and that way try and have it take off. They didn't actually succeed in the end, but it was really, I thought, a good idea. I have a video for that one, so we are going to show it. I think it is, where is it? It's this one. Yeah. So, well, that's the description of the challenge. So, this was the team trying to fuzz the GPIs and have it take off. Didn't quite take off, but that team managed to get it take off. By the way, yeah, it was secured with a rope, right? Because we didn't want to have the drone fly in the room in the middle of participants. That would have been dangerous. So let me get back to the slides. Yeah, I have a little bit of time for this one. So this one was about a smart glasses challenge. This one was also a multi-stage challenge with different, the first part was easy, then a little bit more difficult. And the idea behind that was that, well, I had a pair of smart glasses and I thought it would be cool for participants, well, to have the opportunity to use them. Of course, you don't like try on smart glasses all the time, do you? And also to hack them. For some of those who saw my talk at it, that was 2 years ago. Well, I did some research on those smart glasses and on malware that could be put on those smart glasses and how they behaved and things like that. So that's where it came from. Actually, here in front of the smart glasses, that's where you have like a small Android device. And that's where you have all the things. So those glasses, they are meant for cycling or running, that tell you how fast you go, where you are on a map, what's the weather like, where's your next friend located, and things like that. Okay. And you can customize it. That's cool. So we decided to create our own application there, the phone glasses, sorry, and to have competitors look into that. When they ran the application, first stage, they would get a QR code. Okay, it was pretty easy. You just needed to scan the QR code and you would get the flag. Except it's on smart glasses, right? So how are you going to take a picture? It's kind of a little bit more difficult. So you had to grab it by ADB, or I don't know exactly how all teams managed to do it, but it was a little bit more difficult. Then the second part, you would have to actually open up a display, a frame which was like hidden. You would then pop up another screen there, which would tell you, well, that there is something to find on the northwest of the room. The northwest of the room, if you didn't have your correct bearings, well, there was a compass on the glasses there. So you could use that and locate a white envelope on a white wall there. Okay. So that was one way to end up and solve the last stage of this X-Men stuff. And we've come to the end of our talk. Thank you very much. So we have here actually plenty of people who helped us design some of the challenges. So thank you to Balda, Fabrice, Antoine, and others. Thank you also to Insomnihack to have us give us the chance to talk here about our CTF. Our next edition will be in December the 14th. It's still in the south of France, so Sophia Antipolis there, and you are, of course, most welcome to come and join us.